So now that we have noted down our requirements, let's calculate the numbers that we need to handle. Our web crawler will be crawling the web all the time in the background. So let's assume that we want our crawler to crawl 1 billion websites in around 1 month. Let's also assume that on average, each website will have around 15 web pages. So that means we need to crawl 15 into 1, 15 billion web pages in 4 weeks. Since we check the throughput in terms of per second query, we will convert this number to per second crawls that we need to handle. So 15 divided by 4 weeks, 1 week has 7 days, 1 day has 24 hours, 1 hour has 60 minutes, and 1 minute has 60 seconds. This gives us the load we need to handle at every second. 4 into 7 would be 28. Let's keep the 24 for now. 6 and 6 would be 36, and we have 2 zeros. So we cancel these 2 zeros from a billion, and we will have 150 million here. Furthermore, like we learned while calculating estimations for Uber, that 24 into 36 would approximate to 1000. So we can simply cut 150 million by 1000, and that would give us 150k. We still have a leading 28 right now. So if we replace 28 by 30, we would need to divide 150 by 30, and that would give us simply 5k. But since we approximated 28 with 30, let's say we have a little bit more than 5k. So let's say that our final result is something around 6k pages per second. Again, there is no need for this calculation to be accurate at all. Now for the scalability of this system, Google is a service that's in the entire world. So let's think about scale of our system. The world population is around 8 billion. So let's assume that our search queries are around 5 billion per day. So once again we need to convert this into seconds. So we say 5 billion by 24 hours into 60 minutes into 60 seconds. We again cut the 2 zeros by billion and we come at 50 million. Once again we approximate 24 and multiplied by 36 to 1000. So that gives us 50k queries per second. Now a lot of these queries would be searched for the first time ever. So let's assume that the unique updates in our DB are around 20% of this number. So we have around 1 billion unique queries per day. Once again with the same calculation we convert it at second level. So we are looking at 10k queries per second for the updates. Let's estimate how much storage do we need to support. Let's assume that the average size per day is 100 KB. We would also need to store metadata around that page, so we take additional 500 bytes. Now 500 bytes added to 100,000 bytes would be a really small change, so we can approximate this to again 100,000 bytes. So the total storage we need to handle for 4 weeks is the total number of web pages, which are 15 billion, multiplied by average size per page, which is 100 kbs. So if we take 3 zeros from billion, that would come out to 15 million, and we apply these 3 zeros to kbs. So kb would become mb. We do the same thing again. So taking 3 zeros from million would make it 15k, and applying those 3 zeros to mbs would make it gb. Once again we do this, again taking 3 zeros from 15k would just leave us with 15, and multiplying those 3 zeros with GB would give us TBs. So we are looking at 1500 TBs, which divided by 1000 would be converted to 1.5 petabytes. If you got confused with these conversions, you may want to check out the course section where I've noted down some important numbers that are really useful for a system design interview. Now when a user queries, let's assume that average query size is 3 words. Average length of one word can be 5 characters, and size of each character could be 2 bytes. So this would give us average query size as number of words multiplied by characters multiplied by size of one character. That would come out to be 30 bytes. So the total size we need to store is 1 billion by 30 bytes, which would give us 30 GB. Now we need to design a scalable system. So let's consider how much storage we need to handle for the next 5 years. Assuming that our system will grow by 10% annually, we can compound this interest to the 30 GB, and that would come out to be 45 GB. For this, either you can evaluate the compound interest formula or you can do it just verbally. For example, for the first year, 10% of 30 GB would be 3 GBs. So at the end of first year, we will need to handle 33 GBs. Similarly, for the second year, 10% of 33 would be 3.3. So adding it to 33, that would give us 36.3 GB. You can keep doing this 5 times for 5 years, or you can just use the compound interest formula. So now that we have estimated our storage, in next slide we'll see how to design our database to handle this storage and the throughput.